Calcium phosphate compounds play a crucial role in maintaining the structure and strength of plants. Calcium phosphate serves as a source of calcium and phosphorus, two essential nutrients for plant growth. Calcium is involved in cell wall development, enzyme activation, and cell signaling, while phosphorus is crucial for energy transfer, photosynthesis, and promoting root development. On this project, I'll be using our waste eggshells. I already washed and cleaned the eggshells first, and now I'll be putting this outside to dry in the sun. Crushing the eggshells before making calcium phosphate is necessary to increase the surface area and facilitate the chemical reaction between the eggshells and acid. By crushing the eggshells, you create a larger surface area for the chemical reaction to occur and increase the reactivity and promote efficient reaction with the acid, leading to the production of calcium phosphate. This allows for better utilization of nutrients present in eggshells and enhances the effectiveness of the homemade Calphos. Heating the crushed eggshells before using them in the process of making calcium phosphates serves two primary purposes. One is eggshells contain some moisture, and drying them before use helps remove any residual water. Moisture can hinder the chemical reaction between the eggshells and acid, leading to a slower or incomplete reaction. Two is heating process also involves a step called calcination. Calcination involves subjecting the crushed eggshells to a high temperature to convert calcium carbonate, which is present in eggshells, into calcium oxide. This conversion is important because calcium oxide reacts more readily with phosphoric acid to form calcium phosphate. The heat treatment by drying the eggshells and converting them to calcium oxide prepares the crushed eggshells for subsequent reaction with phosphoric acid to produce calcium phosphate. This process helps optimize the efficiency and effectiveness of the Calphos preparation. You will notice the change of color when roasting the eggshells. Changes from white to color brown, and this will be ready for mixing. Select a container that is made of non-reactive material to ensure it doesn't interact with the ingredients or affect the chemical reaction. Glass, stainless steel containers are commonly used for this purpose. Ensure that the container is thoroughly cleaned and dried before use to prevent any contamination or interference with the reaction. Choose a container with sufficient capacity to accommodate the amount of ingredients you are using. It should have enough space to allow for mixing without overflowing. Consider using a container with a tight-fitting lid or cover. This helps prevent evaporation, keeps the mixture secure and minimizes exposure to air and moisture. On this project, I'll be using our local vinegar, which came from the sap of the coconut blossom, also known as a coconut water or coconut sap. It does contain various nutrients, including phosphorus. Mix the crushed eggshells with vinegar 1 part shells to 5 parts vinegar. Ensure thorough mixing to promote the reaction between the calcium compounds in the eggshells and the vinegar. When eggshells come in contact with the vinegar, a chemical reaction occurs to the reaction between calcium carbonate in the eggshells and the acid in the vinegar. This reaction is known as an acid-base reaction or acid-base neutralization. This reaction between the eggshells and vinegar helps break down the calcium carbonate into a soluble calcium acetate and release carbon dioxide gas. It demonstrates the ability of the vinegar to dissolve or react with the calcium carbonate compound in the eggshells. Remember to label the container with the contents and the date of the preparation, and keep track of the storage duration. You can use this after 21 days by extracting the liquid from another container and placing this in a cool, dry area or in a room temperature. You can use this for up to 6 months.